Projectile motion series, M&M quiz 2172. Welcome to hecanhelp.com. At t is equal to 0 seconds, a projectile is launched from point A as shown. So this is our point A at 22 meters per second magnitude and 30 degrees with respect to the horizontal. Assume no air resistance and constant acceleration. Assume change in y, delta y, from A to C. So this is point C. Assume change in y from A to C is equal to 0. What is the horizontal displacement AC? So what is this distance AC? Assume positive x is defined as to the right, positive y is vertically up. Is it A, B, or C? Welcome. So horizontal displacement is what we are asked for. Horizontal displacement is horizontal velocity times time, because acceleration along the horizontal is 0. There is no pull or push along the horizontal. It is a projectile motion. So acceleration along the horizontal is 0. That makes this term go to 0. So this is equal to 0. So what does that mean? It means that your horizontal velocity component, which is 22 cosine 30, that remains the same forever. So at point A, what is the horizontal component of the velocity vector? 22 cosine 30. At point C, what is the horizontal component of the velocity vector? 22 cosine 30. And that is 19.05 meters per second. So we already know the x component of the initial velocity vector, and that is 19.05 meters per second. All we need is now time to go from A to C. What is the time to go from A to C? So right now there is nothing else we can do along the horizontal. So what do? We look at the vertical. When we look at the vertical, what do we see? We see that change in y along the vertical equals initial velocity along the vertical times time plus 1/2 acceleration along the vertical times time squared. Initial and final points are the same along the vertical. That means what? Delta y is equal to 0. So we can substitute delta y is equal to 0. So your delta y is equal to v initial y times time plus 1/2. Acceleration along the vertical is negative 9.8 times t squared. So change in y, and that is equal to 0 from A to C. Initial velocity along the vertical is v0 sine 30 times time plus 1/2. Acceleration along the vertical is negative 9.8 times t squared. So you get 0 equals v0 is 22 sine 30 times time 1/2 negative 9.8 is minus 4.9 t squared. Divide throughout by time and you get 0 equals 22 sine 30 minus 4.9 t. Add 4.9 t to both sides and you get t is equal to 22 sine 30 divided by 4.9, and that is 2.245 so many seconds. 2.245 seconds. So that's what I did here on the left. What is the initial velocity along the vertical? 22 sine 30, and that is 11. Time to go from A to C is time t, the unknown. Acceleration along the vertical is negative 9.8. Substitute for change in y from A to C, and that is equal to 0. Initial velocity along the vertical is 11t plus 1/2 times negative 9.8 t squared, and you get time is equal to 2.245 seconds. Now we have the time to go from A to C, 2.245 seconds. We can find the horizontal displacement from A to C, because horizontal displacement is horizontal velocity component times time. Horizontal velocity component is 22 cosine 30 times time times time, and what do we get? 42.77. So don't forget, change in x is equal to the x component of the velocity vector times time to go from A to C. And this is George Mathew, always by your side. Good luck.